Can you tell us your name and a little bit about your project?
Yeah. So my name is Sir Arthur Eddington, and I was born on December 28th, 1882, and I'm currently 30 years old. My work involves Einstein's theory of relativity, and more specifically, proving it to be true. My fascination with Einstein's theory began in 1916 when a good friend of mine, William de Sitter, handed his work on to me. Myself and a few colleagues decided to design an experiment to put Einstein's theory to the test. We were trying to prove if light does actually bend, and to do this, we obtained many large lenses and telescopes to observe light as it moved around Earth. Einstein's theory and my experiment proving it were huge steps forward in the theoretical physics community.
Okay, so what were you guys trying to do or find?
So we were trying to find actual tangible data to support Einstein's theory of general relativity. We proved that light does actually bend around massive objects and coined the term gravitational lensing to describe this phenomenon. So, gravitational lensing is now used to help study and understand the expansion of the universe.
Okay, so where did this project or experiment occur?
The experiment actually occurred in 3 different locations. So, the first step was to measure the stars' positions as they normally are from England. Then, a few months later, I sent 2 teams of scientists to different parts of the globe to measure those same stars' positions during a solar eclipse. I sent 1 team of scientists to a remote island in the Gulf of Guinea called Principe, and another team to Sobral, Brazil. The 2 different teams gave us a higher probability of success, as it was very possible that cloud cover could prevent measurements from being taken at either one of those locations.
Okay, so what other significant events were going on in the world around this time?
Off the top of my head, Mahatma Gandhi began his nonviolent resistance movement against British rule in India. Prohibition was signed into effect in the United States. The League of Nations was founded, and Afghanistan declared independence from the United Kingdom.
Who else was involved in your experiment?
Perhaps, other than myself, perhaps one of the most important people involved in this experiment was Sir Frank Watson Dyson. He's the one that proposed conducting the experiment during the eclipse. He recognized that the sun would be passing through a dense star cluster during that time, and he realized that the light would have to the light from the stars would have to travel through the sun's gravitational field. And luckily, because of the eclipse, those stars' light would be visible here on Earth. And this would allow the team to take accurate measurements of the stars' gravity-shifted positions in the sky. Another important team member was Andrew Crommelin, and he's the one who led the expedition to Brazil, where measurements were also taken. And many other physicists were also indirectly involved through papers they had written or studies that had been conducted, such as Albert Einstein.
And what was your role in this project?
So I was the project leader, or manager, you could say. I formed the team and conducted the majority of the data analysis that I would later base my paper off of.
What impact did your project have on the physics community?
My work proved Einstein's genius and led his theory of general relativity to be accepted as fact worldwide. And it has allowed research to be done into the theory of dark matter and has helped scientists understand our expanding universe.
And what other accomplishments are you known for?
About a year after I finished my work on gravitational lensing, I became the first person to correctly predict the mechanism of the nuclear fusion processes in stars. I correctly predicted that the star's fusion of hydrogen atoms into helium atoms. I am also credited with devising a measure of a cyclist's long-distance riding achievements, and I called it the Eddington number.
Well, thank you for your contributions and your time.
Well, of course.